What if I told you that twinkling light in the night sky, seemingly fixed and eternal, is part of a cosmic ballet so vast and dynamic it dwarfs our wildest imaginings? What if I told you there's a planet out there, a celestial body made entirely of diamonds shimmering in the void? Or that the very fabric of time, that constant, unyielding river we all navigate, actually bends and stretches, slowing down the faster you move through the cosmos? These aren't flights of fancy. These are whispers from the universe itself, clues to its profound and often bewildering nature. Today, we embark on an extraordinary voyage. We're not just stargazing, we're peeling back the layers of reality to uncover 10 mind-blowing facts about the universe, each one a testament to the sheer wonder and complexity that surrounds us. These are discoveries that have humbled astronomers, challenged physicists, and expanded our collective consciousness. Prepare to have your perception of reality stretched, perhaps even shattered, as we dive deep into the cosmic ocean of knowledge. And I urge you, make sure to stick around for our final revelation. Number 1 on our list. It's a cosmic enigma, a puzzle so profound that even the brightest minds in science grapple with its implications, a mystery that reminds us how much there is still to learn, to discover, to understand. So, strap yourselves in, open your minds, and let's get started on this incredible journey. Our first stop takes us some 40 light-years from Earth, a mere stone's throw in cosmic terms, to a super-Earth exoplanet named 55 Cancri E. Now this isn't just any rocky world, it's a place that redefines our concept of planetary composition. Imagine a planet roughly twice the size of our own Earth, orbiting its star so closely that its surface is a searing inferno, a far cry from the gentle blue marble we call home. Its year, the time it takes to complete one orbit, is a blistering 18 Earth hours. What makes 55 Cancri E truly astonishing, however, isn't just its proximity to its star, or its rapid orbit, but what lies beneath its scorching atmosphere. Scientists, through meticulous observation and deduction, believe this planet possesses an extraordinarily high carbon content. Consider the immense pressures and temperatures that must exist within such a massive body, so close to its stellar furnace. These are conditions unlike almost anything we can replicate or fully comprehend on Earth, a crucible of cosmic proportions. Under these extreme conditions, carbon, the very element that forms the basis of life as we know it, behaves in spectacular ways. The theory, and it's a compelling one, is that a significant portion of 55 Cancri E's interior, perhaps even its mantle, could be composed of pure crystalline carbon, in other words, diamond. Think about that for a moment. An entire world, or at least a substantial part of it, not just sprinkled with precious stones but potentially made of them. A treasure trove beyond human comprehension. Visualize it. A planet where mountains might be colossal diamond carats, where valleys shimmer with an internal captured light. This isn't a jeweler's fantasy, it's a plausible scenario born from our understanding of planetary science and chemistry under extreme duress. It challenges our Earth-centric views of what planets can be, pushing the boundaries of geological possibility. It makes one wonder what other exotic materials and formations await our discovery in the galactic neighborhood. The existence of such a world, a diamond planet, serves as a powerful reminder that the universe is far more diverse and surprising than we might naively assume. Each new discovery, like that of 55 Cancri E, adds another layer to our understanding, revealing that the cosmos is a place of incredible chemical alchemy, capable of forging wonders that outshine our most glittering dreams. It beckons us to keep looking, to keep questioning, and to keep exploring the celestial menagerie. Now let us turn our attention from planetary composition to the dramatic end-of-life sagas of massive stars. When a star significantly more massive than our Sun exhausts its nuclear fuel, it doesn't simply fade away. Instead, it collapses under its own immense gravity in a cataclysmic event known as a supernova, an explosion so bright it can briefly outshine its entire host galaxy. But what remains after the celestial fireworks have subsided? Often it's one of the universe's most extreme objects, a neutron star. Picture this, the core of that once mighty star, compressed into a sphere perhaps only 20 kilometers or about 12 miles in diameter. That's about the size of a city, yet it contains more mass than our entire Sun. The gravitational forces at play during its formation are so intense that they overcome the forces separating atomic nuclei. Protons and electrons are literally squeezed together to form neutrons, hence the name. What's left is an object of almost unimaginable density. To truly grasp this density, consider this. If you could somehow scoop up just 1 teaspoon of neutron star material, that tiny amount would weigh approximately 6 billion tons here on Earth. Let that sink in. 6 billion tons. That's roughly the weight of Mount Everest or every single human being on our planet combined, compressed into the volume of a sugar cube. It's a state of matter so alien, so far removed from our everyday experience that it almost defies comprehension. These stellar remnants are not just dense, they are also often spinning incredibly rapidly, sometimes hundreds of times per second, a consequence of conserving angular momentum as the progenitor star collapsed. They can also possess magnetic fields trillions of times stronger than Earth's. These properties can lead to spectacular phenomena, such as pulsars, which emit beams of radiation that sweep across space like cosmic lighthouses, observable from Earth if we happen to be in their path. Neutron stars, therefore, are not merely cosmic curiosities, they are laboratories for extreme physics. They allow us to study matter under conditions of density and pressure that are impossible to replicate on Earth. They test the very limits of our understanding of gravity, of nuclear physics, and of the fundamental forces that govern the universe. Each one is a silent, spinning monument to the awesome power inherent in the cosmos, a testament to the cycle of stellar birth, life, and dramatic death. We often perceive time as a constant, an unyielding river flowing at the same pace for everyone, everywhere. Tick-tock, tick-tock, the steady march of seconds into minutes, minutes into hours. But what if I told you this perception is an illusion, a simplification born from our limited, earthbound experience? The universe, in its profound wisdom, reveals that time is far more malleable, more personal, than we might intuitively believe. This revelation comes to us from one of the greatest minds in scientific history, Albert Einstein. In his theory of special relativity, Einstein unveiled a universe where space and time are inextricably linked, woven together into a four-dimensional fabric called space-time, and one of the most mind-bending consequences of this union is time dilation. Simply put, time passes at different rates for different observers, depending on their relative velocity or their proximity to a strong gravitational field. The faster you move through space, the slower you move through time relative to a stationary observer. Consider astronauts aboard the International Space Station. They are orbiting Earth at about 17,500 miles per hour. While this speed is immense by terrestrial standards, its effect on time is subtle, yet measurable. Over a 6-month mission, an astronaut on the ISS will age approximately 0.007 seconds less than someone on Earth. It's a tiny fraction, almost imperceptible in human terms, but it's real. It's a direct, observable confirmation of Einstein's revolutionary insight. Now imagine traveling at speeds approaching the speed of light, the cosmic speed limit. The effects of time dilation would become dramatically pronounced. For a traveler on such a relativistic journey, years, even decades could pass for them, while centuries or millennia might elapse for those they left behind on Earth. This isn't science fiction, it's a fundamental aspect of the physics governing our universe. Space travel, in a very real sense, is also a form of time travel, albeit only into the future. This elasticity of time challenges our deepest intuitions and opens up fascinating possibilities, at least theoretically, for future interstellar voyages. It means that the vast distances separating stars might one day be traversed within a human lifetime, from the perspective of the travelers. Time dilation reminds us that our everyday experience is just one small slice of a much grander and stranger cosmic reality, where the metronome of the universe doesn't beat to a single universal rhythm. Chapter 4: The Unexpected Aroma of the Cosmos. When we gaze at images of distant nebulae or shimmering galaxies, we are captivated by their visual splendor. We ponder their immense scale, their composition, their origins. But have you ever stopped to consider what space might like? It seems like an absurd question, doesn't it? After all, space is largely a vacuum. How could a vacuum possess a scent? Yet, astronauts who have ventured outside their spacecraft on spacewalks have returned with a surprisingly consistent report. Upon re-entering the airlock and removing their helmets, many astronauts describe a distinct, peculiar odor clinging to their suits, tools, and even the airlock itself. The descriptions vary slightly, but common comparisons include the smell of burnt or fried steak, hot metal, welding fumes, or even spent gunpowder. It's a sharp metallic and somewhat acrid aroma, an unexpected sensory souvenir from their journey into the void. What could possibly be the source of this smell of space? Scientists believe it's not the vacuum itself that has a scent, but rather the result of interactions occurring in the near-space environment. One leading theory points to polycyclic aromatic hydrocarbons, or PAHs, complex molecules that are abundant throughout the universe, found in comets, meteorites, and interstellar dust. These compounds, when exposed to atomic oxygen or ultraviolet radiation from the sun, might undergo chemical reactions that produce these odorous byproducts. Another possibility involves the interaction of high-energy particles from the solar wind or cosmic rays with the materials of the spacecraft or the astronaut's suit. This energetic bombardment could release volatile compounds, creating the unique scent. Think of it as a kind of cosmic static cling, where molecules from the space environment adhere to surfaces and then off-gas once back in a pressurized, oxygen-rich environment. It's the universe leaving its olfactory signature. This unexpected phenomenon reminds us that space, while seemingly empty, is an active and complex environment. It's filled with radiation, particles, and trace amounts of various chemicals, all interacting in ways we are still striving to fully understand. The fact that space has a smell, however faint or indirectly perceived, adds another layer of richness to our exploration of the cosmos, engaging not just our intellect and vision, but even our most primal senses. It's a faint whiff of the vast, untamed wilderness beyond our world. Chapter 5. Our Universe. A grand holographic illusion. Prepare yourselves, for this next concept may challenge your very perception of reality, of what it means for something to be real. We are accustomed to experiencing the world in three spatial dimensions: length, width, and height, along with the dimension of time. But what if this rich, three-dimensional tapestry of existence is, in some fundamental way, an elaborate projection, an illusion encoded on a distant, lower-dimensional surface? This is the mind-bending essence of the holographic principle. Originating from studies of black holes and string theory, the holographic principle suggests that all the information contained within a volume of space, like our entire observable universe, can be represented as if it were written on a two-dimensional boundary surface, much like a hologram stores a three-dimensional image on a two-dimensional film. It posits that the universe we perceive, with all its depth and complexity, might fundamentally be a holographic projection of physical processes taking place on this distant cosmic boundary. It's a difficult idea to wrap one's head around, isn't it? It implies that the third dimension we so readily perceive might be emergent, not fundamental. Think of a credit card hologram, a flat, two-dimensional surface that, when viewed correctly, produces the illusion of a three-dimensional image. The holographic principle scales this idea up to the entire cosmos, suggesting that the pixels of our universe might be Planck-scale bits of information on some vast encompassing surface. While this remains a theoretical concept, it's one that is taken very seriously by many physicists working at the frontiers of our understanding. It offers potential solutions to deep paradoxes in physics, such as the black hole information paradox, and provides a novel framework for unifying gravity with quantum mechanics. Experiments are even being designed to search for evidence of this holographic nature, looking for a fundamental graininess to space-time that might betray its projected origins. If the holographic principle turns out to be true, it would revolutionize our understanding of space, time, and information. It would mean that the reality we inhabit is, in a profound sense, less solid than it appears. It doesn't mean our experiences are not real, but rather that the underlying structure of reality might be far stranger and more elegant than we ever conceived. It's a testament to the universe's capacity to surprise us, to reveal layers of complexity that force us to question the very foundations of our perceived world. The story of the cosmos is still being written, and each new discovery is a new chapter. If these explorations into the strange and spectacular have ignited your curiosity, if they've made you pause and ponder our place in this vast expanse, then our journey today has been a success. I encourage you to nurture that spark. If you enjoyed this voyage through the mind-blowing facts of the universe, please show your support by liking this video, subscribing for more cosmic adventures, and sharing your thoughts in the comments below.